So in the previous video, we discussed how to go about coding a servo. In this one, we're going to expand that and talk about how we can include things such as sensors and other kind of external inputs that control the servo for us. And so in this case, we're going to include a sensor. We're going to include a PIR sensor. And first thing we need to do is actually give that a name within the program. So we're going to call that motion sensor, and we need to attach that to a pin, and so we're going to put it to pin 14. So just a quick note on pin 14, well actually 14 to 19. These are on the analog side of the Arduino, and depending on how you name it, it reads it differently. The same pin, if you were to call it A0, it would be an analog pin. When you call it 14, it becomes a digital read, like an on-off as opposed to an analog read. We're going to be calling it 14. Later on in this video, I'll call it A0. And then the next thing we need to do is create a variable that can store a value. The next thing we're going to do is identify that this motion sensor is an input. So we're going to call it pin mode, and then we're going to say motion sensor, which is the name of the pin, is an input pin. You can create a pull-up as well. I'll speak to this for a second. So what a pull-up is, first of all, we're going to write digital write motion sensor high. So the reason you put in a pull-up is when there is not a pull-up, sometimes a sensor can give readings that are close to the halfway point, and it can flip-flop between high and low. And so what a pull-up is, it's actually a resistor that pulls it into a high position. So it's a 20K resistor internal to the Arduino that pulls it high. Now, if a strong enough sink pulls it low, it will pull low. But if there is this floating somewhere in between, it'll automatically pull it high. And so it helps to get rid of those false readings. So we're going to put that in there as well. So now we got to, first of all, read our sensors. So we're going to take that value and we're going to tell it what to read. So we're going to say digital read, and then we're going to read that pin that we created, motion sensor. So we're going to read the motion sensor, which in a sense is reading pin 14. Then we're going to say if that value is equal to high, I'm going to tell it what to do. We're going to say we're going to take our paper servo. We're going to tell it to go, we're going to say right to 180 degrees. And that's the end of our if statement. And then we can say, if it's not, we can say else. We'll say paper servo right 0. And that's the end of our else loop, and then the end of our entire loop. So that's it. So if the motion sensor is triggered, it's going to go to 180 degrees. If it's not triggered, it will go to 0. And just so that we can follow this along, we're going to actually add the serial monitor. So we can say serial monitor print line high, or why don't we say on. And we will just copy and paste that down here. And we'll say that if it's not, it's off. So verify that. It's all good, and then we can go ahead and upload that. Okay, so right now it's off, and now I move my hand in front of it. It's on. It's off. I'll move my hand in front of it again, turns on. And so when it's on, it goes to 180 degrees when it's off. If I wanted to switch this out for a different sensor, so let's go ahead and actually erase this. So the next sensor we're going to use is called the potentiometer. What it is a variable resistor. Depending where the dial is turned, it allows a different amount of voltage through. We're going to give this a new name then. We're going to call it the pot sensor. And because it's not just on and off, it's actually range, we're going to read this as an analog, not a digital. So we're going to change that to A0 or analog 0. And we're going to just use the same value that we established already. We're going to use that again. Because we changed the name, we need to change that here as well. And we can delete the pull-up resistor because you wouldn't want that. There's not that issue of the voltage floating. We're actually kind of measuring on a kind of graduated line. So we're going to get rid of that. And then we're going to go into our codes. Just like before, we're going to establish what the value is. Now, last time we did digital read. This time we're going to do analog read. And we're going to read that pin, which we call the pot sensor. Really what we're doing is saying read that pin. Okay. Now, the one thing we have here is the way the analog pin reads is when there's 0 voltage, it's 0. And when there's full voltage, it reads 1023. And that's kind of just how it applies numbers to the voltage that's coming in the analog. And the servo that we're using, this particular servo goes up to 180. And so 1023 is just far too much. And so we have to change this value again and map it against a different value. We're going to take that value and we're going to apply a different condition to it. We're going to map it. And so we're going to say map, and then we're going to take that name, and we're going to say 0 and 123. So that's what the analog pins are reading. And we're going to map that to 0 and 180. What that's doing is taking 0 voltage on the input pin, and we're going to say that that value is going to stay 0. But when it's 1023, we're going to make it 180. Now, these numbers here are very arbitrary. These ones on this side, they can change, but typically you'd be doing the full range from 0 to 1023. On this side, if we wanted to have the full dial of our pot sensor, but we only wanted the servo to go from, say, 90 degrees to 120 degrees, we could map the dial all the way down, and that could be 90 degrees here. And we could make this 120 degrees. This way it would give you a 30-degree movement in your servo, and you can go ahead and try this, but we're going to use a full 180-degree movement. So now we've kind of created that variable. Now we got to send that to our servo. So we're going to take that name that we created again, servo. We're going to write that value. And because we want to be able to track what's going on, we're going to print the line for that too. Serial print, and we're going to say degree is, and then we'll write down what it actually is. Print line value. Okay, and like before, we're going to add a short delay. We did this in that for loop of 15 seconds just to give it a bit there. That's the end of our loop. This is a hangover from before, so I'm going to get rid of that. So we'll verify this. Everything looks good, and we'll upload that to our Arduino. And now we'll go to the serial monitor there. And so right now the dial is at 13. So you notice we have the pot sensor set up to our Arduino here, and this potentiometer has 3 wires attached to it. There's a voltage in, there's the ground in, and then it sends an output through the center line there, and it kind of communicates the difference in voltage. And so as we adjust this dial, they'll change the voltage that goes to that analog input pin on the Arduino, which is A0 in our case. And so we've mapped that to the servo, and you can kind of see it adjust accordingly. Let's actually go back into the code, and why don't we actually change this to what we were talking about before. So if we went to, say, 90 and 120, and we upload this again, and now we'll kind of look at how it outputs to the servo. So this is all the way down to one side, and the maximum it can go up is 120. See how that kind of maps different? That's how we use an analog sensor, in this case a pot sensor, and we'll leave it at that.